Hey y'all, exam 2 review. Here we go. And I apologize, my voice is a little bit scratchy. I think I have the beginning of a cold, but okay. So let's review taking the derivative. Here we are, question 1. Differentiate the function. That just means take the derivative. So how do we take the derivative of this? Oh, I need to plug this in first. Okay, here we go. All right, y prime equals, this is the chain rule. We have a function inside a function. So we have this raised to the 10th. So we bring the 10 down and this becomes 9. We keep the inside the same. Remember, we say don't chew the chocolate. And then we multiply by the derivative of the inside. The derivative of 9 is 0, and the derivative of 2x cubed would be 6x squared. So this is an answer. You could also multiply 10 times 6x squared and say 60x squared, 9 plus 2x cubed to the 9th. So that one's that answer. All right, the E rule, remember E to the U is E to the U times the derivative of U. So 9e to the negative 5x is 9e to the negative 5x times the derivative of that, which is negative 5. And I can multiply in any order. So I can multiply, whoops, that's not negative 40, negative 45, e to the negative 5x. And that's that answer. Okay, this is 6, 7x squared plus 5 to the 1/2. Okay, so then we're going to bring down this 1/2 in front, and that would be 3, negative 1/2 outside, and then we're going to keep the inside the same, and then multiply by the derivative of the inside, which is 14x. And so 3 times 14, that gives us 42x, 7x squared plus 5 to the negative 1/2. Or you could write 42x and then the square root of 7x squared plus 5 in the bottom, because negative 1/2 is the same as the square root in the denominator. Okay, so the natural log of u is u prime over u. So the derivative of 7 natural log, we're going to say 7 times, it goes to the derivative of this argument, which is 2x, over the argument itself. Oops. 2 plus x squared. I can multiply 7 times 2x and say 14x over 2 plus x squared. So again, it's the derivative of the inside over the inside. So you don't have natural log in your answer here. Your answer is a fraction when you're taking the derivative of natural log. This one, you notice we have a function inside a function. Anytime you have a function inside a function, that's chain rule. So you pull the 4 down, make it to the 3rd power. That's power rule. Then keep the inside the same. And then we're going to multiply by the derivative of the inside, which is 1 over x. Because the derivative of ln of x is 1 over x. And the derivative of 6 is 0. So that's your answer there. The next problem. Mommy's doing this right now. All right, the next one we're going to do, notice we have 4x. We have 3 to the 8x. We have 2 functions of x, which means we need to do the product rule. So we're going to do the derivative of the first times the second plus the derivative of e to the 8x, which is e to the 8x times 8, and then times the first. So again, product rule, because there's 2 functions of x. If this was just 4e to the 8x, that answer would be 4e to the 8x times 8, should be 32e to the 8x. This is different because there's an x here. So we have derivative of one times the other one, plus the derivative of the other one times the first one. As far as cleaning this up for the answer, you could write 4e to the 8x plus, that's 4 is 32, 32x e to the 8x. This one, we're going to bring the 4 down. So we get 4 e to the x to the 7th minus 8 to the 3rd times the derivative of the inside, which is EX to the 7th times 7X to the 6th. So the derivative of the inside of this is e to the u times the derivative of that u. So all of these are just being multiplied together. So we can multiply in any order. So I could pull this 4 and the 7 and say 4 times 7 is 28. X to the 6th, EX to the 7th, EX to the 7th minus 8 cubed. That's a lot of stuff. Okay, so again, chain rule, do it layer by layer. Let's do number 8. So this one, if it had an X up here, I would say do quotient rule, but it doesn't have an X up there. So if you only have one function of X, my recommendation is to rewrite it if you can. So I'm going to bring this whole thing up front. And when I do that, up to the top, I make it -6. Now the derivative, we're going to pull down this -6 rule, 24, subtract 1, keep the inside the same. And then times the derivative of the inside, 27x to the 7th. And so if you want to simplify, you can multiply 24 times 27, x squared, and then on the bottom, you have 9x cubed plus 1 to the 7th. Again, when you subtract 1, and it's a negative number, it gets more negative. So -6 minus 1 is that -7. And you can multiply this out in your calculator to get that final answer. Number 9, find f prime in the equation of the tangent line. So anytime you say equation of the tangent line, you need two things. You need a point and you need a slope. So I'm going to find my point. I'm going to find my slope. My point, they gave me 2. You find the y value by plugging in 2. So 2 cubed, 3 minus 2 to the 4th. 2 cubed is 8, and 3 minus 2 is 1. 1 to the 4th is 1. So you get 8. So 2, 8 is your point. The slope is the derivative. And this one, we have to use the product rule because you have 2 functions of x. And so I have x cubed, and then I have 3 minus x to the 4th. So I'm going to take the derivative of the first one. That's 3x squared times the second one plus the derivative of the second one times the first one. So let's check. Derivative of the first times the second plus derivative of the second. I had the chain rule here. That's why it's multiplying times -1 times the first. And then I need to plug in 2. So 3 times 2 squared, 3 minus 2 to the 4th plus 4 times 3 minus 2 cubed times -1 times 2 cubed. So we got 2 squared is 4 times 3 is 12. That's 1 to any power is 1. 1 again times -1 times 2 cubed is 8. So I have 12, and then this is going to be -32. So 12 minus 32 would give us -20. Hopefully I did that right. Going fast today. So y minus the y coordinate, y minus 8 equals -20 times x minus 2. And then if you want to rearrange this to solve for y, you would just distribute this -20, so -20x plus 40, and add the 8 over. So y equals -20x plus 48. There you go. Number 10, we're a third of the way through the review. If I'm going too fast, always pause it at any given moment and or reach out to me with questions. This one, I'm not going to rewrite it because there's a function of x on top, not just a constant number. So we're going to do quotient rule. So I have derivative of the top times the bottom minus the derivative of the bottom, which is the chain rule. So it's an 1/8 and then times the 4 times the top all over the bottom, squared. If I squared the 9th, your power to the power, you multiply. So you have like 9 of them and another 9 of them. So 9 and 9 gives you 18. And so trying to clean this up, 4x minus 9 to the 9th minus 9 times 4 is 36x, 4x minus 9 to the 8 over 4x minus 9 to the 18. You could factor this out and simplify it. You could write that there. And then it says, where is the tangent line horizontal? That means where does the slope equal 0? So if I set this whole thing equal to 0, my recommendation then is to factor out to the top. So I notice that I have to the 9th and to the 8th. So you pull out the lowest common multiple. So that would be to the 8th. So you'd be left with 4x minus 9, just 1 power, minus this 36x, all over 4x minus 9 to the 18th. So then this 8 would cancel with 10 of those. And then on top, if you simplify 4x and negative 36x, that would be, what's 36 minus 4? 32. So negative 32x minus 9 over 4x minus 9 to the 10th. We're setting this equal to 0. So now I really just have to care about where the top equals 0. So negative 32x minus 9 equals 0 when negative 32x equals 9. And then you just divide. So your answer would be 9 over negative 32. So quotient rule, we factored out the lowest common multiple, simplified. And then when it says horizontal, you're setting the derivative equal to 0. Because what is the slope of any horizontal line? 0. Hold on. All right, let's do number 11. Use implicit differentiation. Okay, so implicit means you write dy dx after all of the y's. So the derivative of 8x is 16x. And then minus 3y squared dy dx. Minus 0 equals 0. And then solve for dy dx. So negative 3y squared dy dx equals negative 16x divided by negative 3y squared. And so your answer is 16x over y squared. And then if we want to plug in 3 and 4, we'll just plug in 3 for x and 4 for y. These 4's would cancel, so you would just get 3. Use implicit again. Okay, implicit would be 2y dy dx plus the derivative of 5y is 5 dy dx plus 7 equals 0. So I'm going to move over the negative 7 and factor out a dy dx from both of these. So I'd be left with 2y plus 5. Move this 7 to the other side and then divide by 2y plus 5. That's dy dx. And then to plug in negative 2, 2. That's just plugging in 2 for y. 4 and 5 is 9. So that's that answer. Okay, again, implicit. This time you have to use the product rule. So derivative of 5x is 5 times y plus the derivative of y times 5x, because this is the product rule right here, plus dy dx, and then the derivative of that is just 0. And then we want to solve, so I'm going to move the 5x over there and factor out dy dx from these two guys that are left. That'd be 5x plus 1, because there's an understood 1 there, equals negative 5y, because you move it over by subtracting. Divide, and then like the other one, you just plug in to get your answer. Number 14, like implicit differentiation. Okay, so derivative, we need the product rule again. So 2x times y plus derivative of y times x squared minus 12x squared equals 0. And then we would just move over both of those things. So that'd be a positive 12x squared minus 2xy, and then just divide by x squared. And then I will let you plug in the 2 and the 4. Okay, the derivative of negative e to the y is negative e to the y dy dx equals 5x to the 4th minus 4y cubed dy dx. Let's move this over here and that over there. So negative 5x to the 4th equals negative 4y cubed dy dx plus e to the y dy dx. And now I can factor out dy dx. Negative 4y cubed plus e to the y equals negative 5x to the fourth. Divide. And we have your answer. When I plug in a 0 for y, e to the 0 is 1. Okay, almost halfway there. How many implicit differentiation questions are there? Okay, I'm gonna let you do the next. Yeah, I already did a lot of implicit review. So let's do this cost one. Suppose that for a company, we have this for cost, revenue, and then profit. If the production is increasing at a rate of 400 calculators per week, when production equals 6,000 calculators, find the rate of increase in cost, revenue, and profit. Production. Hold on, what's the effect? Right, guys, I had to tend to my kids for a minute. Okay, so let's get back to this one. So this is a related rates type question where we need to write down our given information and take derivatives. So it says production is increasing. So at 400 calculators per week. So that's saying dx dt equals 400 calculators per week because x represents the number of calculators per week. And then it says when the production is 6,000. So this is when x is equal to 6,000. So find how the costs are changing. That means we got to take the derivative. Well, the derivative of 90,000 is 0. The derivative of 40x is 40 times dx dt. So this is the easiest one. 40 times your 400, which gives us this. Our next one is dr dt. And when we take the derivative, we have to say the derivative of 300x is 300 dx dt. Don't forget that part. Minus 2 over 20, because we're bringing the 2 down. And then x, and then also dx dt. So this is where I need both of these pieces of information. So I have 300 times 400, because that's our dx dt, minus, that simplifies to be 1/10. X right now is 6,000 times your dx dt 400, and you could simplify that to be 6,000 times 40. When you multiply that out and that out, the difference gives you 120,000. And then you just subtract this minus that, and that gives you the profit. And this is decreasing, this is negative. So decreasing was the negative piece because we're going to get negative 1, 2, 0, 0, 0, 0 when you do that. And subtract that, take that minus this, and that gives you the rate of change of the profit. So that's number 18. Number 19 says that we have this other cost function, and then it says how fast the cost per month changing when the production is changing at a rate. So that's when dx dt equals 19 and the production is 60. So the derivative of that would be 0.8x dx dt. So it'll be 0.8 times 60 times dx dt 19. So what is that? 0.8 times 60 times 19, 912. So I have a positive number, so this is going to be increasing at this rate per month. Find the critical numbers, increasing, decreasing. So this is first derivative test. Critical numbers, increasing and decreasing means you take the derivative and set it equal to 0. So the derivative for this, we need the quotient rule. So it's going to be 2x times the bottom minus the derivative of the bottom times the top over the bottom squared. So that would be 2x squared minus 6x minus x squared over x minus 3 squared. So 2x squared minus x squared. So we have x squared minus 6x over x minus 3 squared. Critical numbers is where the derivative equals 0 or doesn't exist. So if I was to factor the top, they both have an x. And so I could take out an x. And so I see I have 3 factors, right? 3 possible places where I have an issue. So x equals 0 is a critical value. From here, x equals 6. And from here, x equals 3. Now the function doesn't exist at 3, but that still we need to consider what's happening there. So if I was to do a first derivative test and write down 0, 3, 6, I test points. So say I put a negative number over here, like -1, this would be negative, this would be negative. This is always positive because it's squared. So negative and negative means positive. If I pick a 1, then this is positive and that's negative. So now we're at negative. If I pick 4, this is positive, that's still negative. So it's still negative. Pick something bigger, we're going to get positives. So the function is increasing, decreasing, still decreasing, and then increasing. At 3, we have an asymptote because the original function doesn't exist at 3. So we have a max at 0, comma f of 0. I could plug 0 in here and get 0. And we have a min at 6 is where we have the derivative from negative to positive. So 6, comma, plug in 6. 6 squared over 6 minus 3, so 36 over 3, so 12. So that's how you would do that problem. Use the graph of f to find where f prime is greater than 0. So remember, f prime is positive whenever f is increasing. So this function's increasing from here to here. So that's where its slopes would be positive. So -4 to, or -3 to 3. So here, f prime is positive -3 to 3. F prime is negative on negative infinity to 3. Yeah, so it's C. All right, so we have to have these points, f of -1. F of -1 is 1. F of 0 of 1 is -1. So already it can't be that one. Or that one. Or that one. Well, that was pretty easy. Just with the points itself, it has to be this one. But then we can also see f prime, so equals 0 means that it kind of flattens out, which it does at all these, has horizontal tangent lines. F prime is greater than 0, so it should be increasing at those 2 places and then decreasing. So it is D. So this is a graph used to give a graph of f. Where is f prime greater than 0? So that way it would be where we're increasing. So from here to here and here to here. So increasing from -6 to 2, it looks like. And 8 to infinity. Okay, this is different. This is f prime. So now we're going backwards. This is where that's not a max. Okay, so f prime, so the zeros of f prime are where the maxes and mins are of the original function. So see at -3 and at 5, I have zeros. And the derivative, it's negative here. It's below the x-axis. And it's negative here. And it's positive here. because this is looking at f prime. So that means the original function is decreasing, then increasing, then decreasing, because the original function is a cubic since this is a parabola. And so as far as maxes and mins, this would be a min and this would be a max. So you're looking to see where this one is below the x-axis. F prime is below, means f is decreasing. And f prime above, right above 0, is f is increasing. So just be careful that you pay attention if you're given f or f prime, because you read the graph differently. Find the interval so much f is increasing and decreasing. Okay, so increasing, decreasing, I take the derivative. I get 4x cubed minus 16x. We set it equal to 0. Factor out of 4x, so I'm left with x squared minus 4. And so I have 4x and then x minus 2 and x plus 2. And so I can put 0 and -2 and 2 on a number line. And I plug in the test points in here. So take -4. This would be negative and negative and negative. 3 negatives is a negative. -1, that would be negative. That would be negative, but this would be positive. 1 would make this one positive, but that one's still negative. And something bigger than 2, they're all positive. So the function is increasing from -2 to 0 and from 2 to infinity. And decreasing would be the opposite things. If I need to draw, it says sketch a graph. I would find the x-intercepts. So factor out x squared. I'm left with x squared minus 8. So we have x equals 0 and then plus and minus root 8. And I know it's a quartic, and then I know at -2, I have a min, and at 2, I have a min. So something like that. This is F, indicated concavity, concave up. So we're looking to see where it looks kind of like a smiley face, right? So smiley face would be this interval here. So from 0 to infinity, here. And the point of inflection is where it changes concavity, which would be at x equals 0, because it's like frowny face here. So your point of inflection is kind of like halfway in between the max and the min, where that concavity just changes. And it doesn't look strange there. It's just kind of the natural place where it changes from concave up to concave down. And again, this is F. Now concave down would be where it's frowny face. So frowny face from here to here. So negative infinity to -2. So this one. Find h double prime. That just means find the derivative and then find the derivative again. So the first derivative would be -16x subtract 1, -3, plus 18x subtract 1, -7. H double prime then would be 16 times 3, that's 48. X to the -4 minus 18 times 7, 126. X to the -8. Concave up, concave down. That just means we have to take the derivative 2 times. So the derivative of the first one, -6x to the 5th, plus 36 times 5, 180. X to the 4th minus 36, then take the derivative again, -30x to the 4th, plus 720x cubed. And then let's see, if we divide that by 30, we get 24. So take out -30. So I'd be left with x to the 4. Actually, hold on. Take out -30x cubed. So then you're left with x minus 24. So we get x equals 0 and x equals 24. Then if I put those on an F double prime line, I have negative, I put it in here, that'd be negative. that would be negative, so that would be positive. If I put a 1 here, oh no, wait, I'm sorry, there's a negative out here also. Oops, my bad. I wasn't thinking about that -30. That's 3 negatives. 3 negatives means that this is negative. If I put in a 1, this is negative, this is negative. No, 1 would make this positive. So that would be positive because it's 2 negatives. And if you put in a bigger number over here, this is going to be positive and positive, but you have this negative in front, so negative. So concave down, concave up, concave down. So your points of inflection are at 0, and then you would plug in up here. So 0, 7, and at 24, plug in 24, whatever you get, if you need to give X and Y coordinates. But the places where the concavity changes, that's the points of inflection. Okay, so I need to sketch the graph. So first we have f of 0 is 6. F of 3 is 0. F of 6 is -6. So it looks like both of these are contenders. But then it says f double prime of 3 equals 0. So it's a possible point of inflection, which that one looks like it is. Oh no, actually, f of 3 is 0 is only right here. I think this is the only one that has those 6, 0, and then -6. Because that'd be point of inflection, and then concave down from 3. No, concave up, sorry, happy face. And then we see that there's horizontal tangent lines at 0 and down here. And then f prime is less than, that means decreasing. So yes, decreasing here. And then the second derivative is negative, that would mean concave down here. Yeah, so it's C. Okay, you guys work on this review, make sure you can do it alone without having to check the key for every answer or check the video review for every answer. And then you'll know you're ready. So good luck on the second exam. Try your best.